Thank you for joining us for today's webinar about the M-Series Waterjet that we've recently introduced. If you want to check this out later, you can go to our website WARDJet.com, and the M-Series can be found under the Waterjets area, large formats, and then go to M-Series. I've got that page pulled up here. The idea with this machine, as it says here at the top, is to give you a very large platform for cutting large sheets or putting multiple sheets up and setting up zones where you can cut front and back. The M-Series is available in sizes from the M2540, which has a cutting envelope of 2.5 meters front to back and 4 meters left to right, or 8.2 feet long by 13.1 feet wide. Then we've got the M5040, M7540, and M140. In Imperial, the cut area for these models would be 16.4 feet long and 8.2 feet wide, 24.6 feet long by 8.2 feet wide, and 32.8 feet long by 8.2 feet wide. These all come standard with 12 inches or 300 millimeters of z-axis travel, and optionally can have up to 36 inches or 1 meter of z-axis travel. A second and third Z-carriage are optional for increased production, so you can cut with 2 or 3 heads at the same time. Spreader bars are available if you want more than 3 cutting heads. A key feature with the M-Series machine is the programmable spacing on the Z-carriages. If you have a machine with 2 or 3 Z-carriages and you've got a large part that takes up most of the width of the cutting area that can only be cut with 1 cutting head, the other Z-carriages can be parked in these parking areas on each side of the machine. Then with 1 Z-carriage you can cover the entire cutting area. Other options for the M-Series are things like 5-axis cutting and drills and more. The M-Series is designed to be very high speed, very high acceleration. It's rated for up to 2,000 inches per minute. This makes a very good machine not only for abrasive cutting, where you want to wrap it as quickly as possible from cut to cut, but also for water-only cutting, where you can realize the benefits of rapidly moving from cut to cut, and also while you're cutting. With that, let's go out to the machine and take a closer look at some of these features.
So I'm here with Jimmy. Jimmy is one of our mechanical engineers that worked on the design of this machine. So Jimmy, tell us, when you first started designing this machine, what were some of the goals?
Yeah, this new M-Series is replacing 2 product lines, the R-Series and the Z-Series. And we're trying to do a couple things. We're trying to make it more manufacturable, more modular, and then improve upon a few key performance metrics like speed and acceleration.
Okay. So how fast can this machine go now?
We can go up to 2,000 inches a minute, and acceleration is up to 1 meter per second squared. So quite a bit better than previous machines.
Right. So obviously great machine for abrasive cutting, but also for people that are looking to do large sheets, water-only cutting. This machine really delivers high performance.
Yep, it'd be a good platform for that kind of thing.
Great. Well, tell us a little bit about the idea on the cross beam, what we're looking at here.
Yeah, the cross beam is a large box section. We have the rack and rail mounted on top of the beam, where it's up and out of the way of the Waterjet blast, abrasive blast. And all of those key critical features are machined in one setup, so they're all very accurate relative to each other. And kind of new for our Waterjets is this crossbeam overhangs the risers and allows a place for each head on the far left and far right to park.
So ultimately this crossbeam can have 3 cutting heads on here. Right now we've got it with 2. We've got head 1 parked over in the left parking zone. Head 3 could be parked over in the right parking zone. And that gives you that entire coverage over the entire cutting area. Because we've designed this machine to perform well at high accelerations, we have a new Z-carriage on here. We're using an aluminum extrusion, which helps to simplify the design, reduce weight, and yet can also handle additional accessories that will be mounted on there. For example, we'll be offering things like drill spindles if you want pre-drill composites, or spreader bar if you want additional heads on here. Inside, there's a ball screw, so that'll stand up well to a lot of Z-axis motion, as well as having those additional components mounted on that Z-carriage. Also inside, the motor uses a belt reduction, and it's mounted upside down, which helps to reduce space and reduces components to also save weight. Okay, Jimmy, tell us what we've got here.
Yeah, new for this machine, the drive system is using direct mount iso flange pinions. That's a system that gives very good concentricity and allows us to use a very small pitch diameter pinion. It lets us use a lower reduction gearbox, which all leads to better accuracy, lower backlash, all those good things that we want.
One of the key objectives when designing this machine was to keep good loading access around all four sides. Since these side beams can be up to 10 meters or 33 feet long, it's important that these side beams are below the lip of the tank so you can load over the side of the tank. Got this heavy-duty angle iron here, which helps to protect the drive system and the bellows. The side beams are mounted directly to the floor and laser aligned during the installation process. One of the things to look at when designing a system for high acceleration is the routing of the high pressure lines. With a more traditional low acceleration water jet, those high pressure whips can be 10, 12 feet up in the air, and as the crossbeam moves back and forth, those are going to move back and forth. Slow speeds, slow acceleration, not a big issue. When you get up to the speeds and accelerations that we were speccing this machine for, that's going to dramatically reduce the life of those high pressure lines. So what we've done is along the long side of the machine, the y-axis, high pressure lines go through cable track, and then we'll run across the back of the crossbeam. And then here we've got these brackets to support these high pressure lines. So when those Z carriages are moving back and forth across the crossbeam, they've got good support to reduce any sort of twisting. So that'll maximize the life of these components. And this is Benjamin. He's another one of our mechanical engineers that played a vital role in the design of this machine. So tell us about the tank design, what we've done differently on this machine.
Yeah, so we wanted to continue with kind of the same design as we've had on our previous tanks, but make it better, of course. So the first thing you can see here is we have a toe kick, but rather it's a little bit lower than most of our standard machines that come up to here. Gives you the ability to kind of lean, and you've got a nice flat surface to lean up against. And then talking more about the tank, because this is a big machine, we wanted to be able to incorporate the ballast into the tank itself. It's got a welded in plate, and then in order to clean the ballast, if you have any abrasive or debris get in there, there's actually a top plate that will seal against the very top of the ballast with a seal, a bulb seal. And it's very effective and gives you the most amount of volume. And so we get about 2.5 to 3 inches of water level travel in the tank itself.
So I imagine with a certainly a large cutting area like this, very important that we have those grates in there as flat as possible. So having the adjustable support slats to support the grates helps us get as flat a surface as possible, which is really critical when you're doing 5-axis cutting.
Absolutely, yeah, because this machine is so large and can go up to 10 meters in length with a 4-meter crossbeam. It's important that we have adjustability in the cutting surface, and especially for the apex, a 5-axis component of the machine. So one thing that we did, we incorporated an adjustable slat design into the tank, and that works off of the slat having slots in it and giving the ability for it to be leveled and jacked.
During the installation process, the installer will go around with basically a plumb bob and adjust those support slats, make sure that those grates are as flat as possible in that tank. Okay, let's go ahead and do some cutting. I've got 3 sheets of material up here, some 1/4 inch thick 6.35 millimeter aluminum, or aluminium if you prefer. 4 foot by 8 foot sheets, 1.2 by 2.4 meters. So I've got these couple different orientations. On the left, I've got the short edge going across the front of the tank, and then the long direction going back. And then over here, we've got 2 sheets with the long direction going this way. So gives you an idea of the different ways that you can lay out your sheets on the table on these larger format machines. The program we'll be running, be doing some head spacing, head sleeping, and such. So maybe not the most efficient program that you'll see, but more to show off the different capabilities of the programmable head spacing and the ability to park cutting heads outside of your cutting envelope so you can take full advantage of the entire cutting area with one cutting head if you need to. So with that, let's go ahead and start cutting.
As we're watching this cutting video, which is about a 13-minute segment, I'll cover a couple of things to keep it interesting, hopefully. After this little intro, I'll go over some of the features of the Move Controller software. But first, I want to talk about a couple of the ways that the programmable head spacing can be used. The M-Series comes standard with programmable head spacing. In this video, you'll see it cutting with one head, we'll see it cutting with both heads, and we'll see it cutting with head 2 only. Programmable head spacing gives a lot of capabilities when processing large parts. There are a couple of unique ways that our customers are using it. For example, we have one customer that does large discs. They purchase a machine with 4 heads, and they'll cut with 2 heads on one ring in a mirror fashion as shown in this video here, while the other 2 heads are doing the same thing on another disc right next to it. In the area in the middle where the heads can't both be cutting, one head will shut off and then the other head will finish the ring off. Another customer does large parts like this. This part might be 6 feet or 1.8 meters in diameter, and they'll have cutouts arrayed around the part like this. This shape isn't their actual shape, obviously, I can't show that, but something maybe somewhat similar arrayed around the part in this fashion. You can't cut with both heads in the normal sense where head 2 does the exact same motion as head 1, but with mirror cutting, they can cut one of these with head 1 and then they can be mirror cutting this one with head 2. In this way, they can dramatically increase their production. The M-Series ships with our latest version of the Move controller software that you're looking at here. These blue crosshairs here represent the 2 cutting heads that are on this machine and are currently active. Over here on the top left we have buttons to control head 1 and head 2. If we click on these arrows, we can expand this panel, and we've got buttons here for turning water and abrasive on and off automatically and manually for Z1 and Z2. Down here you can control if you want a particular Z carriage to be active or not. If you're just going to be cutting a program with a single head and want to park head 2 out of the way, click on the sleep button and that sends the Z carriage to the top of the Z travel. And you'll notice that the blue circle for that head disappeared over here. Then you can click on the dock button if you want to park that Z carriage entirely out of your cutting area. In the top right hand corner we have outputs that can control heads 1 and 2 for manual water and abrasive on and off, auto on and off, as well as timers to time things like abrasive when you're calibrating your abrasive flow. And then you've got buttons for pump on and if you want to switch to low pressure on the pump. Normally when we're going to cut, we click on these 2 buttons here that put the head into automatic mode for water and abrasive. Now down here in the bottom middle we can click on the plus button to choose a program to cut. I'll go ahead and load this program. It shows a cross here for the cutting head. Then you can do things like if you want to cut multiples of this part, you can click on the part and choose array and specify how many rows and columns and spacing between the rows and columns, and then click on accept array and it'll grid it out for you. Also you can do things like rotate and mirror as well as reset back to original. Based on how you're logged in, you can lock people out of being able to change things like the feed rate override. In the settings area, under users, we've got our different user levels. And then on the activities, you can specify who can do what. Since right now I'm not logged in as anybody, I can't do anything. So let me log in as an admin. And if we go back into settings, Right now, operator level and higher can adjust the feed rate. So if we change that to, for example, maintenance level, and then I go and log in as operator level, and then down here, click down here, we can see that we can't change these values or move the slider. Over here on the right hand side, we have buttons for things like zooming to the extent of your cutting area. You can use your scroll wheel to zoom in and out. Also, being a touchscreen, you can use your fingers to pinch zoom in and out like you would on your cell phone. Over here we have a ruler button, so we can use that to click a couple points on the part and see the XY dimensions of that array that we just made, as well as the diagonal between those 2 points. The move button allows you to move in either incremental or absolute mode in any axis. And then the offset area allows you to save positions on your table. So this offsets tab is for work offsets from G54 to G59. You can see the X, Y, and Z locations for those work offsets. And then you've also got positions tab where you can save XYZ position on your table. So then you would move your cutting head to this saved position, start your program from a G92 location from these start points. And then in the maintenance area, you can track the life of your consumable items and get notified when items are getting towards the end of their life. Down here in the lower right hand corner, we've got things like jogging. Right now we're in continuous jog mode. In continuous jog mode, you've got 3 speeds: rabbit, turtle, and snail. Each of those can have their own speeds assigned to it. If, for example, you want to move slower in snail mode, click down here, go into jog settings, and specify a speed for that mode. There's also incremental jog. Again, there are 3 presets for this. If we click on this 1/1000th of an inch and I click down here, I can zero my coordinates. I then, for example, can jog up in Z. Each time that I click on this button here, it'll move by 1/1000th of an inch. If I activate the 10,000th, each time I click on there, it goes up by 10,000th of an inch, or a 1/10 of an inch. And these values can also be customized by clicking down here and going into that jog settings that we looked at just a few moments ago. And down here are those values. Down here it shows us our absolute X, Y, Z, A, and C values based on where we are on the table. If you click down here, it'll zero those values out so that when you move, you'll be able to see how far you've moved by. Click down there again to zero those numbers out again. And on your lower right hand corner, other things you can do is adjust feed rate override. So up here, if this is set to 100%, we would be cutting at 100% of the program feed rate. If you want to cut a bit faster because maybe you programmed the material for one thickness, but now you're cutting it out of a different thickness rather than reprogramming, you can use this feed rate override and you can adjust it. In this case here, we'll be going 25% faster. Over here we have a button for controlling the ballast. You can click on that and that'll either raise or lower the water level. In the lower left-hand corner, we have information about the estimated cycle time for the program, and then the actual time, and then how many parts are to be run in the queue and what program that we're on. You can set this up so that once it's done with one program, it'll go immediately to the next program and start cutting. Essentially, you can manually make a nest of parts if you don't already have a nesting package. If we want to cut something else out of this same material after this array is done, first of all, I'm going to lock this program into position and jog to where I'm going to want to cut the next program. Then click down on the plus button to add another part. It puts that into the cutting area. Again, if I want to, I could array that. If I want to cut something else, again, lock that part into position and then pick another part. Jog to where you want to cut it. And then lock that into position. Now down here in the lower left-hand corner, we can see the 3 programs that's going to run in the sequence that it's going to run them in, as well as the estimated cycle time for all 3 programs. When you're ready to start cutting, down here at the bottom, you can click on the Run button. And if you want, you can have the CNC file shown here in the background. And the crosshair shows us where we are on the part. If anything ever goes wrong, or you just want to stop the part to inspect it, you can click on the Stop button, and then click on the part, and do things like jump to pierce point, or jump to any point. So if you lost your cut partway through that last hole, and you do jump to any point, you can jump back to a point somewhere on that cut where we're still cutting well, and then move to that location and then resume. If we stop again, click on the part again, and choose jump to a pierce point. I just want to jump to the next pierce point. I just have to be in the general vicinity of lead in, and when I click, it'll find that pierce point, and then you can jump to that point. In this video, we'll see a little bit of high-speed foam cutting. We'll start off cutting with 2 heads on the 2 sheets on the left, cutting some large rings. And then third sheet will just be cut with head 2 by itself. This will be cutting at 1400 inches per minute, 35.5 meters per minute. Here's a quick clip cutting some thin stainless at 100 inches per minute. And finally, a quick clip of head 1 rapiding around the entire 2.5 by 4 meter cutting envelope with head 2 parked outside of the tank.